This is the last video for our Excel project for Module 6, which pertains to the central limit theorem. And we have covered questions 1 through 4, and we are about to complete question 5. Question 5 is a scenario for the population proportion. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Out of the 500 people surveyed, 421 responded that yes, they own cell phones. Find the middle 60% of the values for the proportion of adult residents of the city who have cell phones. The question that is being asked first is what is the distribution of the sample proportion and why? And we have learned from the central limit theorem that the distribution of the sample proportion is a normal distribution if the sample size is large enough and the quantities n times p and n times q are greater than 5. Ideally also greater than or equal to 10. So in this space at cell B80, you want to write something along those lines. Again, the distribution of the sample proportion is expected to be normal because, or approximately normal, because n is greater than or equal to 30 and np and nq are greater than 5. The next part is in C82 and C83, enter the sample size and the number of successes in the sample. The sample size is 500 and the number of successes is the 421. So here I'm going to enter the 500 and the 421. And then it says calculate the sample proportion p hat in Excel using variable locations, and then calculate the proportion of failures q hat also in Excel using variable locations. So remember that the proportion is the number of successes divided by the sample size. And q is the complement, so 1 minus p. So we found p hat and q hat here. Part B says, in C88 and C89, use formulas for the distribution of the sample proportion to calculate in Excel the mean and standard deviation of the distribution of the sample proportion. So let's refresh our memories on those formulas. In our final exam formula page, we say here that the distribution of the sample proportion is a normal distribution with a mean of p and the standard deviation of p times 1 minus p divided by n. And when we have an unknown standard deviation, it will be p hat, 1 minus p hat, and divided by n. So the distribution for now for our sample proportion will have a mean equal to p hat, because that is our estimation for the population mean. And it will have a standard deviation equal to the square root of p hat times q hat, which is the 1 minus p, divided by n. Here we are, we found the mean and the standard deviation of the proportion of tablet users. In age 80, use in ArtofStat the normal distribution app to find the middle 60% of the sample proportion values. Take a screenshot of the graph produced in ArtofStat and paste it in the indicated area. Resize the image to fit in the dedicated area of the Excel sheet. So let's go to the normal distribution. We are looking for percentile quantile. We have a mean of 0.842. And we have the standard deviation of the sample proportion, and that we found it to be 0.016312. Let me double check that I have the correct value. Yes. And I want the type of percentile to be a two-tailed, and they're asking me for the central probability, the middle 60%. So I have the middle 60% here, and then on each tail I have 20%, altogether 100%. So the project is asking us to take a screenshot and place it in the dedicated area. So let's take a screenshot. Remember to include the name of the app, the left pane with all your answers, and any tables below the graph. We will place the image here and resize to fit in the space that they gave us. There we go. Very nice. Let's zoom back in. So the middle 60% of sample proportions on cell phone users is between a blank and a blank. Let's see what part C is asking us to do. Part C says, in D92 and F92, enter the proportions in percent form as those are calculated in Art of Stat that describe the middle 60% of sample proportions. So in Art of Stat, I saw that the value of x1 is 0.8283, which is 82.83%. 82.83%. And let's increase the decimal here so that I can just copy what I see. And here the other upper proportion, the upper bound is 85.57%. And again, let's adjust with the increased decimal feature in Excel, the decimal, so that we have what we see in Art of Stat. So these are the answers that we copied from Art of Stat. And then part D will ask us to actually do these calculations in Excel. So enter the central probability as a percent. So remember, when you used Art of Stat, you had to give it the central probability. So either 60% or 0.60. And it wants us to now find the lower bounds and the upper bounds. For the lower bound in D95, it says use the normal inverse function to find the lower bound of the middle 60% interval. And you notice here that the middle 60% interval leaves a 40% probability on each tail. That will be the alpha. If the confidence level is 60%, that will be the alpha. And half of that probability is 20%. So to find, if someone here had an 80% central probability, then I would have a 10% on the left and a 10% on the right. If someone here had a 70% central probability, I would have a 15% and a 15%. So the question is, without entering manually the value, how do you calculate this 20% from the 60%? If when you enter it in Art of Stat, how does Art of Stat, after you give it only the 60%, how does it do those two calculations? So the 20% is half of what is left after 60% is subtracted from 100%. So The central probability is called the confidence level, which is what you want the central probability to be. And the two tails are called alpha, and we will see that in the next chapter. Alpha is the probability that you are not within the middle 60% or the middle confidence level percent. How do we find each one of those places of all those probabilities? You remember from our chapter discussion and our notes discussion that this is half of the remaining probability of the complement. So I want to do that. I want to use the normal inverse. And it's asking me for the probability. And the probability will be half of the remaining out of the 60%. So I'm going to do 1 minus whatever probability the user enters. And then I will divide that by 2. This is the probability in the left tail. And then it wants the mean, which I found here in part 5b. And then comma, it wants the standard deviation, and that concludes the use of this inverse function. And this cell here in E wants you to just copy the cell that you see on your left and format it so that it is a percentage here, up here. So choose for this to be a percentage, and then choose for this to be to have only 1 decimal place. Let's see if it wants only 1 decimal place or if it wants 2 decimal places. Let me see what our project is asking. Enter the mean and standard deviation, enter the probability as an algebraic expression in terms of the central probability. How does the probability in D94 determine the probability in each tail? If your work is correct, E95 should agree with the probabilities. I don't see what I was expecting to see here, that it will want us to round to the nearest 10th. I'm wondering if we have to either leave those percents with only 1 decimal point, or if we have this here that is by default at the nearest 10th, if maybe we want to increase the decimal place to make it 2 decimal places. I don't see any instructions in the project, therefore I recommend that maybe we want to go back to 5C and reduce the decimal place as Excel was by default gave it to us, so that at least when we convert these things to percents, they actually look like what Excel will give us. So how do we find the upper bound for the interval? Remember that in Excel, the CDF and the inverse work with the probability on the left tail. Now, if your central probability is 60, and the probability on each tail is half of the remaining, then the probability to the left of 0.8557 will be your central probability plus the half of the tail. So when you are using here normal.inverse, this probability needs to be stated algebraically and not explicitly typed. So you want this probability to be the 60% plus the probability of the left tail that you calculated earlier. And this was 1 minus that 60% divided by 2. So this will be the probability to the left of the upper bound. It will be the left tail that was to the left of the lower bound plus the central probability that contains the interval. So then I need to put a comma. I need the mean from cell C88. I need the standard deviation from cell C89. And this concludes the inverse function. And I find the probability here as a decimal and on the right it becomes a percent. And the project now says that if you have done a good job, if your work is correct, the cells in column E, 95 and 96, should agree with the probabilities in D92 and F92 that was in row 92. So the question that we have to ask ourselves is, are these cells in column E that we calculated in Excel the same with the cells, the values that we found in Art of Stat and we entered in row 92? And if they agree, then we have completed the project correctly.